Just doing a quick sound check, guys, and then we should be good to go. That's good. All right, guys, welcome. Wow, it's been a while, hasn't it been? When was this last time I saw you people? I can't even remember. I guess, sorry, I was a little bit delayed, guys, because I just had to come back from school. And I kind of saw that little message from Ryan, so Bailey Atkinson and Jake Patterson, big welcome. But look, let's actually get to work today straight away. I guess what we've got is just some Q&As here. Stacey wants to go through some excellence questions. Yes, Reva, you can actually get excellence by only answering excellence questions in maths. I just need to find some questions. I know people have been sending me some questions. Like, I've got such a huge backlog of questions. It's ridiculous how busy I've been this year, and I knew something was always going to fall out, and I kind of been falling out with this. What's this? I've got a calculus excellence question. Maximum volume. Yeah, grab the bug. Grab the pug. No worries, JJ Dutch. Yeah. How do you find the equation from where you can't locate the vertex? No worries, no worries. Chrissy, you're probably looking at like intercept method. Kinematics, quadratic, completing the square, merit excellence. No, I'm not Rylex. I'm just kind of having a look at it and just trying to see what I can do. Now look, what I might do is I know there's probably some of you guys here that are wondering, hang on, where's my level 2 playlist? Did I actually put it here? That's the question. No, I didn't. That's the problem. Playlist, just give me 1 second. Here we go. How do I get rid of this? Mathematic session 1. Remove from Mathematic playlist 2. Alright. So if you guys are just, sorry, I know I kind of got distracted there. Just trying to kind of put it. I know I spent a lot of time going through this particular playlist here. So I'm just going to pin this playlist at the top here. So that playlist that I've actually pinned there is about 12 hours worth of algebra. So anybody that's actually watched that 12 hours of videos have already told me, most of them have told me, like they either walked away with a merit or an excellence for it. So keep that in mind. Like, and even if you're just going for achieved just in algebra, that playlist that I've pinned in the comments, it's definitely worth watching. It's definitely hard to I never actually made one Reva of every year. I think I should make one. I was hoping to make it this year, but I got caught up with a few things and never really got around to it. Merit and excellence questions for algebra, and I'm just trying to look through my email. Actually, I'm gonna be honest, guys, like my email, I'd have to go back quite a bit. So if you do have any kind of like really quick questions you want to go through, can you just chuck the questions up on email? My email is linked there on at the bottom of the screen, and what we'll do is we'll try and answer some of those questions. So if you can actually email it to me. Instagram works, but the problem is it's a bit of a pain to try and copy Instagram into my tablet here. So what I'll do is I'll just hang around for maybe a couple of minutes while you guys send me some questions on that email. All right, and then we'll actually get started with these questions. What am I doing? Syncing wire. Sync. So yeah, so if you do have any questions, just flick it over on that on my email, please. I'll try and load up Instagram as well, just in case, if you guys are sending, because I know I've got a massive backlog of questions that I just haven't got to yet. Okay, let's see. Sorry, I'm in the wrong account. It would help if you're in the right account. +1. All right, Jacob. Jacob, I've actually done that question already, man. 2C. It's actually in. There's a video of it already up. All the exam papers that I've already done it before. So have a look on. Have a look in the my playlist, man. I've already done that question. I don't want to kind of go through questions that I've kind of done again. That's all. Callum. Okay, so Callum, you're looking at plus and minus function and explain how to use it. I'm assuming you're talking about square root of a number there, because when you yeah, so like, I mean, one quick little thing that I want to do is this. I was actually working, I think on Saturday I was working with some kids on parabola question, right? And basically what happened was, like, I actually saw a couple of you guys doing this. Like, let's say we've got like, sorry, I'm just going to go through this really quickly, but as I'm waiting for some questions there. But this is just something with quadratic, and I know this question pops up, right? So let's say we've got a parabola. I don't know, I'm just going to make up this equation here by now. So I'm just going to call this something like negative 2/3 x minus 5 squared plus 7, for example. All right, and this is just a pure example here. If y is equal to I'm trying to think what's going to be 50, what is x? Now there are some people here that don't actually use the graphics calculator. If you use the graphics calculator, you can just put both of these graphs in the graphics calculator and kind of work it out. Now if you don't have a graphics calculator and you want to work this out, what you can do is you don't need to expand the quadratic. I want to show you guys a really quick way of kind of like solving this without actually having to expand. So what you'll have is, you might actually put this as 50 is equal to negative 2/3 x minus 5 squared plus 7. Now I'm not going to expand this at all, as I said to you. I'm going to get rid of the minus 7 first, sorry, plus 7, which when it comes to the other side is going to become minus 7, and I've got negative 2/3 x minus 5 squared. Now 50 take away 7, we've got 43, and we're going to get negative 2/3 x minus 5 squared. All right, now the next step is to get rid of the negative 2/3, so I will just go 43 divided by negative 2/3, or you could actually write it like this as well, 43 times 3 over negative 2. And I think this one is a terrible question because it's actually not going to work. I'm just going to change that minus to a plus. This is what happens when I start making up questions on the spot. So we're going to put that as positive 2, all right? So what we're going to get is, we're going to end up with 43 times 3 divided by 2. So I'm just going to quickly do that on the calculator. 43 times 3 divided by 2 gives me 64.5. So 64.5 equals x minus 5 squared. Now this is where you actually use that square root plus or minus thing, right? Because when you take square root of both sides, what's going to happen is you're going to get plus or minus square root of 64.5 equals x minus 5. So you can actually say x is equal to 5 minus square root of 64.5, and then x is equal to 5 plus square root of 64.5. So it doesn't really matter, right? Like it's just another quick way of actually doing this when you're dealing with quadratics. So you don't have to actually expand and kind of work through it. So hopefully, Callum, that actually helped you with that little question. Rakesh, you have given me this question here. All right, this is actually a great question, guys. This is an algebra word question. I'm gonna try and see if I can cut and paste it. I might have some problems, or it might take a bit of time to actually to sync up. I don't know where this question is from. Now let's try syncing this. Jason, surprisingly, I actually sing that song with my kid every now and then. Spotify playlist. When I'm actually there's a song called not song. I think there's a playlist called, it's a live YouTube track, Limitless. Really good music to work out to. But this is not syncing, man. Come on. Why do you do this to me? This always happens, eh? Like, oh, here we go. Here comes the question. Yeah, I saw someone asking me for a calculus question, and I saw kinematics, so we'll actually talk a little bit about kinematics, all right? Level 3 version of this. Ted, we're going to be doing it later on, man. I'm just going to try and get rid of the level 1s and 2s. Okay, so let's have a look at this question here. What we got? Mirrors is twice as high as its width. It has a wooden frame which is rounded at each corner of the top. Width of the frame is 9. Width of the frame. Okay, width of the frame is 9. Area of the wooden frame is the same area of the mirror. Find the height of the mirror including the frame. Right, so if looking at this question, there's a couple of things that we need to do. And I think it's always a good idea to start with these word questions that you can actually, how do I say it? Like, you can actually put a couple of numbers in it, right? And just kind of have a look through it. So for example, if I put the width as 5, then the height is going to be 10. If the width is 6, then the height is going to be 12, and so on. So what we can do, the very first line that we have is we can actually say h is equal to twice as high as it's wide. So we can actually say it's 2w. All right. Then what happens is we replace the h. We're going to replace it with 2w. Now, what it actually says is that it has a wooden frame, right? And it's rounded at each corner. So basically, we've got 1, 2, 3, 4 quarters. So if you think about it like this, that 4 quarters is going to form a circle. And this circle has a radius of 9 centimeters. Now the next part we're going to be looking at is those 4 side panels. All right, so I'm going to start putting some numbers for this. So this is going to be like 5, 6, 7, and 8. So we've got the radius, this area of the circle, plus we've got zone 5, zone 6, zone 7, and zone 8. So zone 5 has a height of 9 and a base of w, so that's going to be 9w. Zone 6 is going to be 2w times 9. Zone 7 is 9w plus zone 8, which happens to be 9 times 2w. All right, so once we have that, we can actually put area of the circle as pi r squared. So that's going to be pi times 9 squared. And then here we've got 9w plus 18w plus 9w plus another 18w. So we've basically got 54w plus 81 pi. I've just I guess you could do that, Tom, but all I have done is I've just put them as zones. Like maybe I should have put it as like different colors. Maybe that might have actually helped. So all I'm trying to do is zone 6 and 8 are the same. Zone 5 and 7 are the same as well. So you could have actually put that as letters. All right, so we got 54W and 81Y. What's the next thing? So that's the area of the grid itself. Now on the other side, we've actually got area of the mirror. So the mirror's area is going to be base times height, or in this case, it's going to be W times 2W. 2W times W, so we're going to get 2W squared. So last step, it says width of the frame, the area of the wooden frame is the same as the area of the mirror. So we've got 54W plus 81 pi is equal to 2W squared. So at this point, what you've got is you've got a quadratic equation set up. So 0 is equal to 2W squared minus 54W plus 81 pi. Cool. So then what we have is, all we've got to do is we've just got to put this in the graphics calculator and kind of solve it, and we should be good to go. So get the graphics calculator. We're going to go into quadratic mode. So equation, what do we got? F2 polynomial, 2 degrees, and we're going to put in the values, which is 2 minus 54 and 81 pi. So I'm just going to put that in there. And when we solve it, we're actually getting two values for the width. So the width could be 6.0827, or it could be 20.917. But it's asking for the height. So your height could be double of that. So it's going to be either 12.08. Oh, hang on. I'm just going to make this simpler, guys. Sorry, just being a bit lazy. So this one would be like a 12.16 or 20.92 times 2, whatever that is. So 41.84. So you're basically looking at two answers for the height there. I'm just looking at anything else that I missed. No, I didn't miss anything else. All right, so what does the 54W plus 81 pi? Stacy, that was actually the area for the brown frame. That's what it stood for. I did do it this weekend, Windwalker. How to send the picture? Dashil, because it actually says that the frame, so if you look at it, that circle, right? That circle part is like this. So that's your first quadrant. Then your second quadrant is actually here. Third one is here. And then your fourth one is here. So they're like the four corners of the picture frame that actually gets added up. How did I get 9W and 9? Yep, so basically if you look at it like this, I'm going to go right here. So if I look at zone 7, this height is 9, and then the width, so if you look at it, that's 9 and that's W. So we're going to get base times height, which is 9W. Did I mess it up? How did I mess it up? How did I mess the quadratic up? Oh, minus 81 pi. Ah, oops, sorry. Yeah, fair enough. So that means I should get a different answer. Oops. We can make mistakes. That's all right. Yeah, you're right. That should be minus 81 pi. That's fine, because I mean, like, what are we going to get in this case? Yeah, I mean, you're still getting, like, sorry, guys. Yeah, that should have been a big mistake there. That should have been 31.09. And of course, you cannot get negative 4.09 for an answer. So that's not going to work. So then the H is equal to 62.18. Sure, thanks for picking that up. You can do it without a calculator, but you got to do quadratic formula for that. So you still have to go like x is equals minus b plus or minus b squared minus 4ac. All right, optimization. I've got a really nice question that was actually sent to me here. So this is a calculus optimization question. We'll have a look at it and try and go through this, all right? Just trying to zoom into the photo, guys. Just give me a second. This is gonna work. Hopefully this works. So this is like I don't know where this question came from, but somebody sent it to me and we're gonna have a look at it. But it's basically like it looks like it's a cone that's actually inside a rectangular box for shipping or something like that. Right, we're just waiting for that to sync up a little bit and then we should be good to go. Okay, I know quite a few guys are asking for kinematics. Look, I'm gonna be honest with you guys. Like, there is a very good kinematics session that I did last year, which is actually worth the full watch, which I'll try and find it. All right. So for those of you guys that want to catch up with the kinematics, is basically go in here, have a look at this next playlist that's coming up there. There is some kinematic old tutorials that I did, which actually is which is actually there. So go check it out. Rylux, I'm just answering questions, man. So I mean, like, if there's anything particular you want to have a look at, have a look at the old tutorials there. It's definitely worth the watch then, kind of trying to figure out, because I'm kind of just catching up with like some of the questions that I didn't actually answer. Kaizo, it depends. Like, I've pinned a message there with a playlist. That's for algebra, so that's like 12 hours worth of stuff in there. That should pretty much cover you. Why was the radius 9? Because if you look at it, this is where your circle is. And because this part is actually worth 9, that's why the radius of that circle is actually going to be 9. Don't you have to add 18 as it wants frame and mirror? Did I mess it up again? No. Stacy, tangents is there as well in the calculus playlist. All right, look, let's have a crack at this question here, which is an optimization question. So, all right, so one thing about these types of questions is you are always going to be given the formula, right? And if you're not given the formula, you're in a bit of problem. But considering that they give the formula at level 3 in the formula sheet, you should be all good to go. So what's happening here is a couple of things that are happening. So we've got a cone is to be packaged in a square base rectangular box for shaping within a constraint. The sum of the 3 dimensions cannot be larger than 150. Okay, so the width and width cannot be larger than 150. So use calculus to find maximum volume for a cone that will fit in this box. Okay, so what we've got here is you kind of need to like look at this. We've got the volume equation, right? The volume of the cone is 1/3 pi r squared h. Now, really, what I would say is this. What I would say is this. F9. Hang on, did I miss something earlier? I might just put that question up. I just saw that real quickly. 9 to the power of 4 is x minus 53. What is x to the power of 4.5? That's an interesting question. All right, now look, I'm going to come back and finish this question first before I drift off to another question. Now, when you are doing optimization, it's really important that you want to have everything to be in the same variable. So if you look at this particular volume equation, the problem is you've actually got 2 different variables. You've actually got radius and you've actually got height as well. So what you need to do is you need to get rid of one of them. But if you look in the box itself, the box is actually saying width, width, and height. So what we have to do is somehow get rid of the width and replace it with r. Now if you look at this cone, the cone's radius actually goes from the center to the edge. As for the width, it's actually going from edge to edge. So the first thing we can kind of write down is the width is equal to 2r. All right, that's the first thing we're going to write down. The width is equal to 2r. The next thing that we know is we know that width plus height has to be less than or equal to 150. But because of that, what we're going to do is we're going to replace w with 2r. So we're going to get 2r plus h has to be less than or equal to 150. Now, realistically thinking about this question, we would have to say that we have to actually have this equation equal to 150, because I'm trying to think, if you want to find the maximum volume, you want to have the maximum dimension of 150 centimeters, right? So what we're going to do is we're going to rewrite this as 4r plus h is equal to 150. Because if it's less than 150, you're not going to get the maximum volume. So we're going to go with the maximum possible distance there. How do I know w is equal to 2r? Because from the center of the cone to the edge is 1r, and if I go the other way, that ends up being the other r. Okay, so once we do that, we've got 4r plus h equals to 150. And the next step is we want to actually get rid of h. So what we're going to do is we're going to write h is equal to 150 take away 4r. Once we do that, what we actually have is we've got h in terms of r. So we can write volume is equal to 1/3 pi r squared. And instead of h, what we're going to write is pi r squared 150 minus 4r. Okay, now what we have is we actually have gotten rid of h, and then you can actually leave it in terms of r. Yeah, sorry guys, look, I'm just kind of trying to do a couple of things here, but if the chat's going to go a bit crazy, I'm quite happy to kind of just put a slow mode on, even slower than what it is, just because I know people are trying to kind of get through their work, and then we don't really need the banter here at the moment. Yeah, so that's all. Can we just keep the chat to a minimum unless you have a question or anything down, please? Would appreciate it. Cool. So once we have got that all under the same variable, then it's pretty much straightforward, guys, because all you have to do is just expand. So we've got this times 150, so we're going to get 150 times 1/3 pi r squared minus 4r times 1/3 pi r squared. So what we're going to get is volume is equal to 50 pi r squared minus 4/3 pi r cubed. So with that in mind, what we're going to do is we're going to now differentiate. So when we differentiate, we're going to get 50 times 2 is 100. So we're going to get 100 pi r minus 4 pi r squared, because both of the 3's are going to cancel out each other. I've just rearranged the 4r. I brought it over to the other side, James, so it becomes minus 4r. Now the reason, Dulina, the reason why I did that was because if they say the maximum, if they want to try and find the maximum volume, you want to have the maximum distance of 150 centimeters, right? Because if you have the dimensions less than 150 centimeters, then you're not actually going to end up with the maximum volume. So that's why we kind of have to put it equal to 150. Yeah, I know it's an inequality, James, but we're trying to find the maximum volume. So that's one of the reasons why I would actually get rid of that. All right, so now once we've put this, we've calculated the volume equation, we put this equal to 0, because 0 is when, so V dash is equal to 0 for max. So we're going to get 0 is equal to 100 pi r minus 4 pi r squared. Now r is a common factor, so I'm going to take it out, and I'm going to get, and I'm also going to take out pi as well, and 4. So I'm actually going to take 4 pi r as a common factor, which means I'm going to end up with, this is going to be 25 minus r. I hope that's right. And then we can actually say 4 pi r is equal to 0, or 25 minus r is equal to 0. So we're going to get r is equal to 0 in the first case, and in the second case r is equal to 25. So once we've figured out that r is equal to 25, we can actually go back to the question. It says find the maximum volume and find the dimensions of the box. So they're not only asking you to find the maximum volume, they're also wanting you to find the dimensions of the box. Now the dimensions of the box is W, WH, which is 2R, 2R, and H. Now we can actually say, because R is 25, one of our width is going to be 50, 50, and then the height is going to be 50, because all of those three numbers have to add up to 150. And also we need to find the volume of this cone. So volume of the cone is 1/3 pi r squared h. So 1/3 pi times 50 squared times 50. And I guess we can kind of leave the answer like that, because which is going to be 625,000, I think. Brain is starting to slow down today. So 50 to the power of 3 is, yeah, see, I told you something was wrong. 125,000 pi over 3. I think that's in millimeter cubed. All right, I'll try and answer some questions for you guys on the side there. I know this question keeps coming up. How did I change the inequality to an equal sign? And And the reason why I did that was because, again, guys, I know I said it a few times, I'm trying to find the maximum volume. If I want to find the maximum volume, I want to use the maximum possible number for the dimensions. And the maximum possible number for the dimensions in this question is 150. All right, and because it's 150, and if I go anything less than 150, I'm not going to get the maximum volume because I have a small box to deal with, and so I'm not going to get the maximum volume possible. So to fit within that constraint of 150, I want to make sure that however big the biggest box that I could have, all three sides, that's the width, the two widths, and the height, has to add up to 150. Oh no, what did I miss now? Let me put some line numbers, and maybe we can actually figure out where I made a mistake. What did you do at the top? At the top, I'm guessing 17, 18, 19. This is the dimension of the box because you had height, width, and width. Line 18. Line 18, I was trying to figure out what the dimensions of the box were. Line 12, I know that the when you differentiate and put it equal to 0, that's when you're going to find the maximum. Line 21, 19. Oh, yeah, I see where the mistake is. Thank you very much. Sorry. Yeah, that should be 25. You guys are absolutely on the money there. So what's it going to be? 3125. There we go. Sorry. Now I know where my mistake is. Yeah, Elizabeth, I know you keep asking me that, and I thought I shared it. Just give me like 1 second. I'll just find that link because I saw it somewhere and I was like, ah, man, I need to share this. And I keep forgetting. And where is it? +1. Did I put this? I thought I put this in the website, but let me just check. No, I didn't put it in the website. That would suck, man. All right, so where is it is the question. Where did I put it? I don't even know where I put these ones. Can I share? Share entire manage access. Anyone with link can view. All right, let's try this link here. Okay, try that to see if it actually works. Yes, it does work. Okay, beautiful. Let me just chuck it up on my website so that I know people are still 2022 whiteboard. Pages, if I can put it, whiteboard. How do I just add a link? New link. Link is that 2022 whiteboard. Done. Sorry, Elizabeth, I've been meaning to do it, but just way too much things I'm trying to do at the moment. All right. Whoa, 17, 18, 19. Stacy, 17, 18, 19 was just to figure out what do you call it? What the dimensions of the cube or the cuboid is. I'll see if I can get some time tomorrow to try and. But don't think I'll have time. When will I have time? Tuesday. I can do it in the morning. Have a look at this playlist, Thomas. You wanted kinematics. I think it was like in 2020 I did some couple of really good sessions on kinematics. Will this be an excellence question? I would like to think so, that this would be an excellence question, Kate. All right, yep. Going to the next lot of questions. All right, how many more we've got? Oh, wow, we've got like 6 questions. Where do I even start from? Casio, let's go with your one. Casio, the question looks very familiar, but I think I might have done, I think that looks like a, sorry, not Casio, Kaizo, the question you sent me, I think it's from an exam, so I think I have done it. So have a look at the exam paper, dude, because I think I have done that question, all right? Joe, Jeff. Joe, is that a level, I'm going to reply to your email, because that looks like a level 1 question. Yep, Devan, we did your question, that's fine. Herschel. Upside down questions. Okay, let's do a calculus question, guys. This looks a bit wonky, but we're gonna try and put another calculus question in here. Rotate left 90. I hope I got the whole question, because sometimes you miss a part of it and then it kind of sucks. All right, let's have a look at this calculus question here. It's gonna take a while to sync up again, I believe, but let's see how it goes. All right, here we go. This is the next question. By the way, while this might be an excellence question, I would strongly recommend you guys to kind of have a look at this question, all right? What have we got? P, f of p. Dashel, it doesn't look too bad. Like, I'm just trying to think of how I would actually approach this question. Function has a tangent at a point ppx that passes through the origin, right? Okay, so check out this, all right? This question is actually not so bad. It is just gradient. You just got to try and figure out the gradient, all right? I don't know where I found, like, somebody sent me this question, so I'm just going to kind of do it quickly because it's not too bad at all. So what we've got here is, first, we've got f of x is equal to ax squared plus b. All right. Next is we're going to differentiate this. So f dash of x is equal to 2ax. All right. So this is the gradient function. Now comes the fun part of this. All right. What they're asking you is they are telling you that there's a tangent at p fp. We don't know what those points are, but it passes through the origin 0 0 where blah blah blah, yeah, whatever. Now it says show that the equation of the tangent is y is equal to this, right? Now here is the thing. You know this. Equation of a line is y minus y1 is equal to m times x minus x1. So that's how I would I start it like this? No. Yeah, well, yeah, kind of. I also know that the gradient at P, so at the point P, I need to find out what the gradient is. And I know that the gradient is going to equal 2 times A times P, which actually equals to 2AP. Because remember that I substitute the x value instead of x, and I'm going to get the gradient at P as 2AP. Now, the other thing to notice is that that gradient is the same, like that blue line that I've actually highlighted is, actually I shouldn't put blue, let me put a different color so I can show you guys what I'm trying to do here. So 2AP is the actual slope. Okay, so that's something to keep in mind. Now what we also know is, we know what the gradient is. Gradient is change in y. Is that going to work? Over change in x? No, that's not going to work. What else could we do? Why am I stuck in this? Ax squared plus b 2 root abx. It's one of these little trick questions, isn't it? Yeah, I could do y equals mx plus c. If I do y equals mx plus c, I'm just going to get y equals to mx plus c. C is going to be 0 anyway. So I'm going to get y is equal to, but I need another point. Tom, it's not that I'm getting stuck, man. It's just like they ask you different things and I'm like, you kind of go, what's the trick part that they're trying to do in this case? Why would you use that? See, I thought about doing it like this, but then that actually gives me f, because if I go y gradient is equal to y2 minus y1, which is x2 minus x1. Actually, no, I can, what about doing it like this? Because I know gradient is equal to 2AP, y2 is f of p over f of p minus 0, p minus 0. Would you guys agree with that? Like, because all I've done here is I know that the gradient is equal to 2AP. And if I find the gradient between 2 points, so I've got 0, 0 there, and I've got p and f of p there. So let's get rid of this. So the 0, 0 actually comes from there, because the gradient is actually going from f of p, p f of p to 0, 0. Now here's what I can do. I can rewrite this as 2AP is equal to f of p over p. That means I can actually say f of p is equal to 2AP times p, which gives me 2AP squared. And that's a good thing for us, because we've actually got rid of f of p. So the point that we're working with right now is p and 2AP squared. That looks right so far. So now if I put that as equation of a straight line, I still don't know how they get the square root of AB, but let's try and figure it out. We've got f of x, no. They've actually done it slightly differently. F of p is equal to AP squared plus b. Okay, I'll see what they're doing. There's like so many components to this, man. Like this is just one of those annoying little questions. But anyway, I went back to the original equation, right? Because f of x is equal to ax squared plus b. Then what I did was I substituted p to figure out what f of p is. F of p is AP squared plus b. So with that in mind, I can actually say that AP squared plus b is actually equal to 2AP squared. Now you don't need to reflect the point. All I'm doing is I'm just playing around with the gradient, and I'm trying to play around with the f of p itself. So then what I've got is b is 2ap squared minus ap squared, which means b is equal to ap squared. All right, so that's what I have so far. And because I know the gradient is 2ap, what can I do here? What can I do here? And I want it in terms of square root of 2ab. So because y is equal to mx plus c, y is equal to m happens to be 2ap, x, that's the gradient, so gradient function times x, plus c. Now the c part is equal to 0, so I don't have to worry about it. So y is equal to 2apx. So somehow I need to go from 2ap to 2 square root of ab. So if you look at it here, we can write this as b over a as p squared. And then we can say that p is equal to square root of b over a. Then coming back and substituting that p there, we're going to get y is equal to 2 times a over square root of b square root of a x. So y is equal to 2 times a times square root of b times square root of a x. And so we're going to get a and square root of a cancels out with that square root of a. Wow, ugly, but long question. Now look, what I'm going to do is I'm going to put in a whole lot of stacks of numbers here so that you guys can actually ask me questions, because I kind of just needed to work my own head around this. So we're going to put 1, 2, 3, 4. Did we need this? Yes, we did. 5, 6, 7, 8, 9. And then we're going to go 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Whew. 23 lines, but let's see where we got. At line 4. Okay, so Kaiden, what I did at line 4 was all I went was 2 times a times p, because when you want to find like a gradient at a particular point, so let's say you want to find when gradient of what's the gradient when x equals to 2, you actually put it in the gradient function. You'd actually put f dash of 2. That's pretty much what I've done here with line 3 and 4. Line 18, how is the gradient 2ap? Because remember, this part right here is the green highlighted part is the gradient. So all of that is actually connected. So because m is actually equal to 2ap, I've replaced m with 2ap for line 18. Line 21. 21, when you take square root of b over a, you can split it up, because remember that when you have x over b as cubed, like exponent rules, is x cubed over b cubed. So when you actually have square root of x over b, you can write that as square root of x divided by square root of b. Dashil, that's cheating. I'm not going to go from line 1 to 23. Geez, Teddy, I've got no idea, man. These are just... Yeah, I don't know if this is a double T question, because I would... There's a lot in it, but this whole... this thing that I'm going to highlight in the pink, that part is very important for calculus. They're starting to show up a little bit more questions like that, where you're going to have to use the gradient equation. So in line 22... So you actually have a divided by square root of a. Remember that a in the numerator could be written as square root of a times square root of a divided by square root of a. And so those two square root of a's kind of like cancels down. Now I think it's a single T question. Rakesh, hopefully that that helped. In line 7, 8, 9, what I was trying to do was I was trying to eliminate f of p. But did I need to do that? Yeah, I did need to do that because I needed to figure out a way to get rid of f of p. Because look, if I have gradient function and I put f of p minus 0 over p minus 0, I can't really do anything with it. So I need to figure out what f of p is. And so that's what I was trying to do. I was trying to kind of like do lots of things to try and see where the connection was actually being made. Kieran, it's not a bad question, man. Like, to be honest, it's if you understand like the basics of it's just there's a lot of basics in here that you're gonna kind of have to it's not like a standard bread and butter excellence question. You got to go, right, this is, you know, I did this stuff in level 1 that I got to use. I did some rearranging with integers, not integers, powers of powers that I got to use here. So it's just a combination of a lot of different steps there. And that's what's happening with line 10, 11, 12 as well, because I'm trying to figure out what f of p is. 5 to 7 was, again, to get rid of f of p, Dashel. Like, I needed like a couple of statements for f of p. 20 to 23, it is getting rid of that a in the denominator. So line 21 to 22, hopefully that little extra bit that I worked on helps. Yeah, lovely, lovely, lovely question. All right. Lucy. Oh, man. These are these sideways. Okay, so we've got a kinematics question by the looks of it. Guys, I'm going to do one more kinematics question, and I'm going to call it because I just... Yeah, I need to call it for the night after this kinematics question. But let me just grab this last kinematics question. Look, if I have some time... I doubt I will, but I'm trying to think. Do I have some time tomorrow to do some of these questions during the daytime? No, I don't, because I got still. Oh, damn it. Yeah. So anyway, let's just kind of do this last question, and then we will call it a night. This is kinematics here. Paste. Just wait for the question to load up. Rotate left 90. Is it kinematics? No, I think this is not kinematics. This is a quadratic cubic, actually. Yeah, sorry, I'm not going to do this. Sorry, it is a level 2. Sorry, Lucy, I was having a look at something else and I thought it was kinematics. But I'll leave that question there. I might do that later tomorrow night, Lucy, with that question. Got a lot of algebra. Okay, Zoe, let's have a look at your calculus question. Is that question a level 3 or a level 2, Zoe? Because that looks like a level 3 question. Oh no, they've actually given you the D. Oh wow, it is a level 2 question. Okay, I might come back to that. Another calculus question. What's this? I want to pick up like one kinematics question, man. Oh, actually, this question is a real quick one, man. I can do this one. We'll do the area under the curve question, guys, because that's a nice, simple one to finish off the night in. Just rotate 90. All right, let's see if we can try and sync up this last question. JJ Dutch, I just need like I need like a 10-minute break, and then I'm gonna do like a level 3 quick integrate. I think a differentiation question at level 3. So yeah, probably like that's why I'm trying to wrap this thing up real quickly. Just one excellence question I wanted to do. for the level 3s anyway. Let's sync this book. It's the annoying thing. I just gotta wait for these questions to kind of load up. Well, to be honest, Zakia, it's the same thing my wife keeps telling me. Like, don't push yourself. But I don't know. I just kind of get dragged into this and then start going on. But anyway, let's go. This last question for the night. It's a nice one because I know it pops up and it's a good question to kind of. I mean, if we know how to do the excellence version, you're gonna be pretty sorted with this type of questions. All right, so let's have a look at this one. What we've got here is rectangle PQR is dimensioned symmetrically. P is a point on the parabola of ax minus x squared. Okay, so what we've got here is we've actually got this point P. Now, the best way to do this question is to write them as coordinates, right? Like, so we're gonna put the P here as x and y like this. But we know what y is, and most of the time the y is the function that you are trying to put the rectangle underneath it. So in this case, we're going to get rid of the y and replace it with ax minus x squared. Now, the question is asking for the maximum possible area. So if we look at maximum possible area, we have got base, and I need a slightly darker color. I hope it's actually going to show up. No, it's not going to show up. We've got base here, and we've also got the height, which is actually in red. Now, the reason why I went with point P is because I know that x is on one side and x is also on the other side of it, because they're symmetrical, right? So then we can actually say that base is equal to 2x, while the height is, depending on where P is, that's going to define what that the y value of that on that curve is what's going to give you the height. So we can actually say height is equal to ax minus x squared. So if we look at area, we can say that area is base times height, which is 2x multiplied by ax minus x squared. It's symmetrical, right? Like if you think about it, normally you'd go, the x value is actually from here to here, but because it's actually symmetrical, we kind of have to add both. The x going to be on the other side as well. Yeah, JJ, I was pretty happy this morning with the result. All right, so we're going to expand the bracket. We're going to get 2ax squared minus 2x cubed. So this is our area equation. Now I want to show you guys how easy this really is, because all you got to do is differentiate, put it equal to 0. So we're going to differentiate area, and we will get 4ax minus 6x squared. And then we're going to put area is equal to 0 for max. So we can say that 0 is equal to 4ax minus 6x squared. We're going to take out x as a common factor, which means we're going to get 4a minus 6x. So x is equal to 0, or 4a minus 6x equals to 0. We're going to rearrange this. So negative 6x equals negative 4a, and x is equal to negative 4a over negative 6. Or we can say x is equal to 2a over 3, 2 over 3? Yeah, 2 over 3. Now, what we've actually figured out is just the x value. We actually need to figure out what the maximum area is. And we know what the area function is, because that's actually 2x multiplied by ax minus x squared. So we can say 2 times 2a over 3 over a times x, which is times 2a over 3 minus 2a over 3 squared. So expanding this, we're going to get 4a over 3 bracket 2a over 3. Something is not right. Why can't I prove this to be 27? Oh, 2a squared. There we go. That's better. Yeah. Got it, Herschel. I was like, something doesn't feel right. Then here we're going to get minus 2a times that is going to be, is it minus x squared? Why is it going to be 4a? Oh, that's fine. That's fine as well. That's going to be 4a squared over 9. We're going to not simplify. We're going to multiply this by 3 and 3. So we're going to get 6a squared over 9 minus 4a squared over 9. So we're going to get 4a over 3 multiplied by 2a squared over 9. And of course, this is now equal to 8a cubed over 27. And that's what it actually said in the original question. So once again, I'll start putting some numbers and you guys can kind of ask me which line doesn't actually make sense. And then after that, we are gonna call it, guys. Zoe, I've got no idea. Look, I just do these questions for the hell of it. So, yeah. Oh, yep. Thank you, guys, for answering that. Line 16. Line 16, I went from 2a squared, which is 4a squared, and then 3 squared is 9. Hopefully that had made sense, Madalena. How do you know to go to line 15 after 14? Well, you have to, right? Because you just figured out what x is, and so you got to figure out, substitute x into the original area equation to figure out what the actual maximum area is. E in calculus, know your basics, because sometimes their excellence questions just seem to be what do you call it, like they try and mix a lot of some of stuff that you know from like level 1. Where did you get the ax minus x squared? That's from the original question, guys, right there. It says in the question. I can't read that. I think it's CN. Oh no, I can't say whatever it is. You asked me where did I get the ax minus x squared? That's actually from the question. Line 17, I had to make the denominators the same. So that's why I multiplied both the numerator and denominator by 3. JJ, no. I haven't actually marked papers at all. Sophie, have you seen my schedule? Like, I struggle to keep up with just the algebra stuff. It's pretty hard for me to do probability as well. Plus, I mean, I enjoy it, but not as much as algebra. Not so much, Zoe. I think you can still get through it. Line 16, all I'm doing is I'm just substituting 2a over 3, Stacy. In 10, can you take out 2x? Yeah, of course, you can do that. Radman, you can absolutely do that. That's not a problem as well. Yeah, she's my old colleague there, JJ Dutch. She does a lot of the probability and stat stuff. King Gamer, that depends. Like most parabolas, if they are symmetrical, right, you're going to have two x. Like, let me put it this way. Like, for example, if I draw this parabola like this, and if I tell you that this point here is 510, and I actually have a, not 510, let's go 512. So if I say that this point is 512, then you know the height is 12, but the 5 is actually only from here to here. So you've got to double the 5 to get the full base of the rectangle. So that's why I'm actually going 2x, right? So that's why I do the 2x for. DPC, nah, man, I got to do the calculus one. Sophie, it depends. I mean, what do you find easy? Like, if you find calculus easy, I would say spend time on calculus. Algebra always tends to, you need some time to think about it. So I would actually say take some, like I would actually try and do calculus first and then kind of try and get back to algebra after that. That's up to you what you prefer really, like whatever you find easy, you kind of do that first. Darren wants no idea. All right guys, look, what happens if there was more than one shape inside the parabola? Duncan, if there is more than one shape in the parabola, you'll have to add them together. Like, so you'd have to come up with the equation to add those two areas together. Jax, I went to Selwyn College out in Kohi. Dulina, I don't know, Dulina. I really don't know. Like, I don't know anything about the papers. Like I said, I just enjoy doing these kind of questions, right? All right, guys, I'm going to take probably a 10-minute break. And I need to come back and do one more question for the level 3s, which they don't actually know about. So I need to set up that file. So that's basically it from me, guys. Like I said, you guys have a lot of material available for algebra. And for the calculus tutorials, like go to the what do you call it? Oh, I can't say it. The live tutorials playlist. I have it up there. So let's have a look. Where did I put it? So if you go into my main page, under the level 2 calculus tutorials, some of them I named and then I completely forgot about it. So there is some kinematics in there, and there should be some kinematics in 21 as well. So go and have a look. There should be some good revision material there for you guys anyway. Enough to kind of get you guys over the line. Budgie, I don't mark any papers, Budgie, unfortunately. I go on holiday. Tom, I teach at Ormiston Junior College. She does DPC. I think it's called Snedden Maths. I thought it was... Oh, Liz Snedden. Yeah, there you go. Just look up Liz Snedden on YouTube. You're going to find her. All right. What are we up to? That's us. So guys, I'll leave you guys with that, and I'll catch you guys tomorrow morning for just to wrap up those last few questions that came on email. But yeah, don't want to be doing too much because would prefer that you guys actually doing some prep work rather than, you know, sitting here trying to catch up with this. But if not, yeah, if I don't see you tomorrow, good luck for your exams, and I'll catch you next time on the streams. All right, we'll be back at 7:30, Arjun. Yeah, cool. Catch you guys.